What if I told you that beneath your feet right now, there's a ball of molten metal spinning at over 1,000 degrees Celsius, and it's the only thing standing between you and complete planetary annihilation? What if that furnace suddenly went cold? Picture this. You're scrolling through your phone, maybe watching this video, when suddenly every compass on Earth starts spinning wildly. Birds fall from the sky, confused and disoriented. The aurora borealis appears over New York City while satellites begin dropping from orbit like metallic rain. Within hours, the very ground beneath major cities starts to crack and buckle. This isn't science fiction. This is what would happen if Earth's core cooled instantly. I'm about to walk you through the most catastrophic scenario our planet could face. And trust me, after 15 years studying planetary geology and working with some of the world's leading seismologists, what I'm about to reveal will change how you think about the ground you're standing on forever. We're going to explore not just what would happen, but when it would happen, how long we'd have, and whether anything could possibly survive. But first, let me give you some context that'll blow your mind. The Earth's core isn't just hot, it's unfathomably hot. We're talking about temperatures that reach 5,700 degrees Celsius, hotter than the surface of the sun. And this isn't some distant furnace we're talking about. This molten metal sphere is sitting just 2,900 kilometers below your feet right now, spinning and churning and keeping our entire world alive in ways you've probably never even considered. Most people think of the Earth's core like it's just some rock that happens to be warm. That couldn't be further from the truth. What we're dealing with down there is essentially a massive electromagnetic dynamo, a liquid metal generator that's been running continuously for over 4 billion years. It's made primarily of iron and nickel, and it's constantly in motion, creating electrical currents that generate something absolutely critical to your survival: Earth's magnetic field. Now here's where things get interesting, and frankly, terrifying. That magnetic field isn't just some abstract scientific concept. It's literally an invisible shield surrounding our entire planet, deflecting deadly solar radiation and cosmic rays that would otherwise sterilize the surface. Without it, Earth would look a lot more like Mars, a cold, dead rock with no atmosphere and no life. So what happens when this 4 billion-year-old engine suddenly stops? The first thing you need to understand is that we're talking about an instant cooling scenario here. Not gradual, not over millions of years like scientists predict might actually happen someday, but immediate. 1 second the core is churning at thousands of degrees, the next second it's solid and cold. The physics of this are mind-bending, and the consequences cascade through every system on our planet, like dominoes falling in perfect, horrifying sequence. Let's start with what happens in the first few minutes, because contrary to what you might think, you wouldn't feel earthquakes right away. The first sign that something catastrophic had occurred would actually come from space. Earth's magnetic field would collapse almost instantly. Now, I know that might not sound immediately terrifying, but stick with me here. Within minutes, every GPS satellite in orbit would start receiving bombardment from solar particles they'd never experienced before. Navigation systems worldwide would begin glitching. Your phone's compass would start spinning randomly. Commercial airlines flying polar routes, which rely heavily on magnetic navigation, would suddenly find themselves flying blind. But here's the really wild part, and this is something most people don't realize. The magnetic field collapse would be visible. The aurora borealis and aurora australis, those beautiful dancing lights usually confined to the polar regions, would explode across the entire planet. Cities like London, Paris, New York, Tokyo would suddenly be treated to spectacular light shows as charged particles from the sun interact directly with our atmosphere without the magnetic field to deflect them. It would be beautiful and terrifying at the same time. People would be filming these incredible auroras with their phones, posting them on social media, completely unaware that they're actually watching the early signs of planetary death. Meanwhile, underground, something far more sinister would be beginning. The Earth's core isn't just sitting there like a ball in the center of the planet. It's actually in constant communication with the layers above it, through convection currents, heat transfer, and gravitational forces. When that core suddenly goes cold, it's like yanking the engine out of a car while it's driving down the highway at full speed. The mantle, that thick layer of semi-solid rock between the core and the crust, would suddenly lose its primary heat source. Now the mantle is already under incredible pressure. We're talking about pressures millions of times greater than what you experience at sea level. That pressure has been balanced for billions of years by the heat from the core keeping the rock in a semi-fluid state. Remove that heat instantly and the mantle begins to contract. This is where the real nightmare begins, because when the mantle contracts, the crust, the thin shell we all live on, suddenly has nothing stable to sit on. Imagine you're standing on a trampoline and someone suddenly deflates it beneath your feet. That's essentially what's happening to every continent on Earth simultaneously. The first major earthquakes would begin within hours, but these wouldn't be your typical earthquakes. We're not talking about magnitude 7 or 8 quakes that make headlines. We're talking about magnitude 10, 11, maybe even 12 earthquakes. Levels that don't even exist on our current scales because we've never needed to measure something so catastrophic. Every fault line on Earth would activate simultaneously. The San Andreas Fault, the North Anatolian Fault, the Alpine Fault in New Zealand, they'd all start moving at once. But it wouldn't stop there. New fault lines would appear as the crust fractures under the stress of the contracting mantle. Mountain ranges would collapse. Ocean floors would crack open. Entire continents would begin shifting positions not over millions of years, but over days and weeks. Cities built near tectonic boundaries, San Francisco, Istanbul, Tokyo, Mexico City, would be the first to experience total destruction. But here's the thing that would shock everyone. Cities that have never experienced major earthquakes, places that were considered geologically stable, would suddenly find themselves in the middle of seismic chaos. London would experience earthquakes. New York would feel the ground splitting beneath the skyscrapers. Even places like Australia, sitting in the middle of a supposedly stable continental plate, would discover that stability was always an illusion maintained by the heat beneath their feet. The human cost in just the first 24 hours would be staggering. Modern cities aren't built to withstand this level of geological violence. Skyscrapers would topple like dominoes. Bridges would snap like twigs. Underground infrastructure, subways, sewers, gas lines, would rupture and create secondary disasters. Gas explosions would rage through cities already devastated by earthquakes. Water supplies would be contaminated or completely cut off. But the earthquakes would only be the beginning of our problems, because as the crust fractures and shifts, it would trigger something even more devastating: unprecedented volcanic activity. You see, the Earth's crust is like a lid on a pressure cooker, and that pressure has been carefully regulated by the core's heat for billions of years. When the core cools and the mantle starts contracting, that pressure balance gets thrown completely out of whack. Magma chambers that have been stable for thousands of years would suddenly become unstable. Every volcano on Earth would become active. Yellowstone, Mount Vesuvius, Mount Fuji, the volcanoes of the Ring of Fire, they'd all start erupting within days of each other, but it wouldn't stop with known volcanoes. New volcanic vents would open up as the shifting crust creates pathways for magma to reach the surface. The skies would begin to darken as volcanic ash fills the atmosphere. This isn't just a regional problem. We're talking about global atmospheric changes that would block out sunlight across entire continents. Temperatures would begin to drop not because the core is cold, but because volcanic winter would grip the planet. And here's where the timeline becomes truly horrifying. All of this geological chaos would be happening while we're simultaneously dealing with the collapse of the magnetic field and increasing radiation from space. The atmosphere itself would start changing composition as volcanic gases mix with increased solar radiation. The ozone layer, which protects us from harmful ultraviolet rays, would begin deteriorating without the magnetic field to deflect the charged particles that normally would never reach it. Plants would start dying, not just from the reduced sunlight due to volcanic ash, but from increased radiation. The entire food chain would begin the bottom up. Ocean collapsing from ecosystems would be devastated as underwater volcanic activity increases and radiation penetrates deeper into the water than ever before. But we're still only talking about the first few days after the core cooling event. The real horror story is what comes next, because as catastrophic as global earthquakes and worldwide volcanic eruptions sound, they're actually just the warm-up act for something far worse. The gravitational effects would start becoming apparent within weeks, and when they do, they'll make everything we've discussed so far look like minor inconveniences. Because when the Earth's core stops spinning and cools down, our planet's relationship with the Moon, with the Sun, with the very fabric of space around us begins to change in ways that will challenge your understanding of how stable our cosmic neighborhood really is. The gravitational changes would unfold like a slow-motion apocalypse, and here's why this part of the story is so much more terrifying than anything we've covered so far. Gravity isn't just some force that keeps your feet on the ground. It's the invisible architect of everything in our solar system, and when you mess with Earth's internal structure, you're essentially rewriting the gravitational rulebook that's governed our planet for billions of years. See, the Earth's core isn't just hot metal sitting in the center of the planet. It's incredibly dense, accounting for about 1/3 of Earth's total mass despite being only about 15% of the planet's volume. When that core suddenly solidifies and contracts, the planet's mass distribution changes dramatically. It's like taking a spinning ice skater who's been turning smoothly with their arms extended and suddenly yanking their arms tight to their body. The physics go haywire. Within weeks of the cooling event, we'd start noticing that days are getting longer, not by minutes, but by hours. The Earth's rotation, which has been slowing down naturally by about 1.7 milliseconds per century, would suddenly decelerate at a rate thousands of times faster. Why? Because the spinning liquid core that's been acting like a massive gyroscope, helping maintain our planet's rotational stability, has suddenly locked up solid. But here's where it gets really wild, and this is something that would catch even scientists off guard. The moon would start drifting away from us at an accelerated rate. Right now, the moon moves about 3.8 centimeters farther from Earth each year due to tidal forces, but with the core cooled and the planet's rotational dynamics completely altered, that drift would increase to meters per year, then kilometers. Picture looking up at the night sky and actually being able to see the moon getting smaller over the course of months. Children who are used to a certain size moon would grow up seeing it shrink visibly in their lifetime. The tides, which are controlled by the moon's gravitational pull, would start behaving erratically as this distance increases. Coastal cities that had survived the initial earthquakes and volcanic eruptions would face a new nightmare. Completely unpredictable tide might come in 20 feet higher. One day the thaw expected flooding areas that have never seen seawater. The next week it might recede so far that harbours become dry land. Marine ecosystems already devastated by radiation and volcanic activity would face complete collapse as tidal pools disappear and reappear in random patterns. But the moon drifting away is actually the least of our orbital problems, because our relationship with the sun is about to get very complicated. You see, the Earth doesn't just orbit the sun in a perfect circle. Our orbit is slightly elliptical, and our planet wobbles on its axis in predictable patterns that create our seasons and long-term climate cycles. These patterns have been stable for millions of years, regulated partly by the gravitational influence of our spinning core and the moon's stabilizing effect. With the core solid and the moon rapidly receding, Earth's axial tilt would start to shift unpredictably. The 23.5-degree tilt that gives us our seasons would begin to fluctuate wildly. Some regions that had been temperate for thousands of years would suddenly find themselves pointed directly at the sun for months at a time, experiencing temperatures that would make the Sahara look like a vacation spot. Other areas would be plunged into darkness that lasts for half the year. The polar ice caps, if any survived the initial volcanic winter, would start melting and refreezing in completely different locations as the axis of rotation shifts. Imagine the North Pole suddenly being located where Europe used to be, or the equator running through what used to be Alaska. These aren't gradual climate changes we're talking about. These are catastrophic repositioning events happening over months and years instead of geological epochs. Meanwhile, the lack of the magnetic field would continue wreaking havoc in ways that most people wouldn't immediately understand. See, our magnetic field doesn't just protect us from radiation. It also plays a crucial role in keeping our atmosphere attached to the planet. Over the course of several months, we'd start losing our atmosphere to space. It wouldn't happen overnight like in some disaster movie, but it would be fast enough that scientists could measure the loss in real time. The solar wind, no longer deflected by our magnetic shield, would literally strip away the gases that keep us alive, molecule by molecule. The first gas to go would be hydrogen, the lightest element, then helium. But eventually we'd start losing oxygen and nitrogen too. The air would gradually become thinner, making it harder to breathe at sea level. Mountains that were once easily climbable would become as challenging as high-altitude peaks. Eventually even those would become impossible without supplemental oxygen. But here's the part that would absolutely terrify anyone who understood the physics. As our atmosphere thins, the greenhouse effect that keeps our planet warm would weaken dramatically. Even if the volcanic winter ended and ash cleared from the skies, the planet would start cooling rapidly. Within a year, we'd be looking at global average temperatures dropping below freezing. Within 2 years, the oceans would start freezing over completely. This isn't just an ice age we're talking about. This is planetary glaciation on a scale never seen before in Earth's history. And yet, somehow, this still isn't the worst part of our scenario. The worst part is what happens to the survivors, because believe it or not, some humans would survive the initial catastrophes. Deep underground bunkers, submarine crews, research stations in Antarctica. There would be pockets of humanity that could ride out the earthquakes, the volcanoes, the radiation, even the beginning stages of atmospheric loss. These survivors would face a psychological horror that no disaster movie has ever adequately portrayed. They'd be watching their planet die in real time, knowing that every day brings them closer to complete extinction, not just of humanity, but of all life on Earth. Imagine being in a bunker with a few dozen people, listening to radio communications from around the world as one by one the signals go silent. First the cities fall quiet, then the emergency broadcasting stations, then the military bases, then the research stations. Eventually there's just silence on every frequency. But the really haunting part is what these survivors would see when they finally emerge from their shelters. The Earth's surface would be unrecognizable. Familiar landmarks would be gone, buried under volcanic ash or shifted by earthquakes. The sky would have a different color due to the changed atmospheric composition. The sun would appear smaller or larger, depending on how Earth's orbit had shifted. Even the stars would look different because the planet's rotation and tilt would have changed our perspective on the cosmos. These survivors would be living on what's essentially a different planet than the one they were born on. And they'd know, with absolute certainty, that it's only going to get worse. Because while all of this chaos is happening on the surface, something even more fundamental would be occurring deep underground. The cooling core wouldn't just stop moving, it would start contracting at an accelerating rate as the metal crystallizes and densifies. This contraction would create a gap, a void between the solid core and the mantle above it. And nature, as we know, abhors a vacuum. The mantle would start collapsing inward to fill this void, but this isn't a gentle settling process. We're talking about billions of tons of rock falling toward the center of the Earth simultaneously. The seismic waves from this internal collapse would make the initial earthquakes look like minor tremors. These would be planet-shaking events that could literally crack continents in half. Any remaining surface structures would be obliterated. Even the deepest bunkers would likely be crushed or buried so far underground that escape would be impossible. But perhaps the most terrifying aspect of this entire scenario is the timeline, because unlike other global catastrophes that unfold over thousands or millions of years, giving life a chance to adapt and evolve, this would all happen within a human lifetime. A person who was alive to witness the initial core cooling event could potentially live to see the complete transformation of Earth into a frozen, airless ball of rock. They could watch their home planet die from beginning to end, knowing that they're witnessing something that has never happened before in the 4 billion year history of our world. And that brings us to perhaps the most chilling question of all. Would anything survive this? Could any form of life on Earth possibly endure the complete cooling of the core and all the cascading disasters that follow? The answer might surprise you, and it has profound implications for how we think about life itself. Because as it turns out, life is far more resilient and far stranger than most people realize. Even in this ultimate doomsday scenario, there are organisms that might not just survive but actually thrive in the new conditions. But before we explore what might actually survive this planetary apocalypse, let me blow your mind with something most people never consider. The life forms that could potentially endure this catastrophe aren't the ones you'd expect. We're not talking about humans in bunkers or even cockroaches in sewers. We're talking about organisms so alien to our everyday experience that they might as well be from another planet entirely. Deep beneath the ocean floor, in places where no sunlight has ever penetrated, there are entire ecosystems that don't depend on the sun for energy. They don't need our magnetic field, they don't care about atmospheric pressure, and they've been thriving in conditions that would instantly kill any surface organism for billions of years. These are the extremophils, bacteria and archaea that feed on chemical energy from the Earth itself. Here's what's absolutely mind-blowing about these creatures. They actually get their energy from the heat and chemical reactions happening deep in the Earth's crust. Some of them live in rock formations miles beneath the surface, in water that's been isolated from the surface for millions of years. They've evolved to thrive in temperatures that would cook any surface organism, in pressures that would crush a human instantly, and in chemical environments so toxic they'd dissolve your skin on contact. When the core cools and the surface world dies, these deep-dwelling organisms would actually face very little immediate change. Their environment is so isolated from the surface chaos that the earthquakes, volcanoes, and atmospheric collapse happening above would barely register in their world. They continue their slow alien existence, completely unaware that an entire planet of complex life had just been wiped out above them. But here's where it gets really interesting. As the surface world freezes and the atmosphere bleeds away into space, these deep organisms might actually start expanding their territory. The cooling planet would create new chemical gradients, new pressure zones, new opportunities for organisms that specialize in extreme conditions. Think about it this way. While the surface becomes increasingly hostile to life as we know it, the subsurface would become a refuge. The slow cooling of the planet would create temperature zones at different depths that had never existed before. Organisms adapted to specific temperature ranges could migrate vertically through the rock, following their preferred conditions deeper as the surface cools. And then there's something even more remarkable that could happen, something that sounds like science fiction, but is actually based on solid biology. Some of these extremophile organisms have the ability to enter a state called cryptobiosis. Essentially, they can shut down all biological processes and become dormant for millions of years, waiting for conditions to improve. Imagine microscopic organisms scattered throughout the Earth's crust, going dormant as the planet freezes, waiting in suspended animation for billions of years until something, maybe another planet crashing into Earth, maybe the sun expanding into a red giant, creates new conditions suitable for life. These tiny organisms could literally outlast our entire solar system. But let's get back to the human survivors, because their story becomes even more desperate as the months and years pass. The few thousand people who managed to survive in deep bunkers or submarines would face challenges that no human society has ever encountered. First, there's the resource problem. Even the best-stocked bunker only has supplies for a few years, maybe a decade if rationed carefully. But we're talking about a disaster that would make the surface uninhabitable for potentially millions of years. These survivors would need to become entirely self-sufficient, growing food in artificial environments, recycling every molecule of water and air, maintaining complex life support systems with no possibility of resupply or repair from the outside world. The psychological pressure would be crushing. Imagine knowing that you're part of the last few thousand humans alive, that your children will never see sunlight, never breathe fresh air, never experience anything resembling the natural world that humans evolved in. The suicide rates would be astronomical. Conflicts over resources would be inevitable. The social structures that hold communities together would crumble under the weight of absolute hopelessness. But some of these groups would adapt, and here's where the story becomes both inspiring and terrifying. Humans are remarkably adaptable, and faced with absolute extinction, we might evolve, not biologically, which takes thousands of generations, but culturally and technologically at a pace never seen before. These underground communities would become masters of closed-loop systems, developing technologies for recycling matter and energy with near-perfect efficiency. They'd learn to grow food in artificial soils, to manufacture tools from recycled materials, to maintain complex machinery with no access to raw materials from the surface. More importantly, they'd develop entirely new social structures designed around survival in a world with no future. Traditional concepts of individual rights, privacy, even family structures would be completely reimagined around the needs of species survival. Every person would become a critical resource that the community couldn't afford to lose. Children born in these underground colonies would be raised with a completely different relationship to the world than any humans in history. They'd never know what it's like to see the sky, to feel wind, to experience weather. Their entire universe would be the artificial environments their parents built. To them, the stories of the surface world would sound like fairy tales, descriptions of a magical place where water falls from the sky and plants grow without artificial light. These underground humans would start diverging from surface humanity in ways that go beyond just cultural adaptation. The constant low-light conditions would affect their vision. The recycled air would change their lung capacity. The limited space would affect their bone density and muscle development. Within just a few generations, they'd start becoming physically distinct from their ancestors. But here's the really wild part. Some of these communities might actually thrive. The total elimination of external threats, the complete focus on efficiency and survival, the absence of the social complexities that plague surface societies, these conditions could create human communities more stable and long-lived than anything in our history. Imagine a society where every person has a clearly defined role critical to group survival, where conflict is literally a luxury no one can afford, where every resource is precious and waste is impossible. These communities could develop technologies and social systems that make our current civilization look primitive by comparison. And yet even the most successful of these underground colonies would face an ultimate deadline. Because no matter how efficient their recycling systems, no matter how carefully they manage their resources, they'd still be fighting the laws of thermodynamics in a losing battle. Energy degrades, materials wear out, even the most perfect closed system experiences entropy. Without access to new energy sources and raw materials from the outside world, every underground colony would eventually face the same fate: slow decline and ultimate extinction. The timeline might be decades, might be centuries, but it would be inevitable. The last humans would die not in some dramatic final battle, but in the slow, quiet failure of their life support systems, surrounded by the decaying technology that had kept them alive far longer than should have been possible. But even as the last human takes their final breath in some underground chamber, the planet itself would continue its transformation. The cooling would continue, the atmosphere would continue bleeding away, the orbital mechanics would continue shifting. Earth would be entering a phase of its existence unlike anything in its 4 billion year history. The frozen oceans would be covered in a layer of ice miles thick. The atmosphere, now too thin to support weather as we know it, would occasionally experience bizarre phenomena as trace gases freeze out and sublimate back into vapor. The surface temperature would stabilize at something close to the background temperature of space, around -270 degrees Celsius. And in this frozen wasteland, something remarkable would start happening. The planet's geology, no longer driven by internal heat, would begin responding to purely external forces in ways never seen before. The gravitational effects of the sun and the distant moon would start reshaping the planet's surface through tidal forces acting on solid rock. The frozen crust would crack and flex as Earth's eccentric orbit carried it closer to and farther from the sun. These temperature variations, tiny compared to what the planet experienced when it was alive, would be the only source of geological activity. Cracks would open and close, ice would sublime and refreeze, and slowly, over millions of years, wind patterns in the thin atmosphere would begin carving entirely new landscape features. This dead Earth would develop its own alien beauty. Crystalline formations of frozen gases would grow like impossible flowers across the surface. The thin atmosphere would create optical effects that would make the sky appear in colours never seen during the planet's living phase. Aurora phenomena, driven by the solar wind interacting directly with the surface, would paint the frozen landscape in shifting curtains of light. And deep underground, those extremophile organisms would continue their slow, patient existence, the only remaining witnesses to what Earth had once been. They would be living fossils of a time when the planet was warm and alive, carrying in their simple cells the chemical signatures of a world that no longer existed. But here's where our story takes its most unexpected turn, because this isn't actually the end. The universe has a way of recycling everything, and even a completely dead Earth still has a role to play in the cosmic story. Our solar system is moving through space, orbiting the centre of the Milky Way galaxy, and over the course of millions of years, that movement would eventually bring our frozen, dead planet into contact with new sources of energy and matter. Dust clouds, radiation from nearby stars, even the gravitational effects of passing stellar systems could begin the slow process of planetary resurrection. The transformation wouldn't happen quickly by human standards, but it would happen, and when it did, those patient extremophile organisms, still dormant in the deep rocks, might finally have their moment to inherit the Earth. Cosmic dust and stellar radiation would begin accumulating on the frozen surface, but this wouldn't be the gentle snowfall you might imagine. We're talking about particles moving at thousands of kilometers per second, impacts that would create tiny explosions across the crystalline landscape. Each grain of interstellar dust would carry with it trace amounts of water, carbon, and other organic compounds, the building blocks of life scattered by dying stars across the galaxy. Over hundreds of thousands of years, these microscopic impacts would start to accumulate into something significant. The frozen atmosphere would begin to thicken again as volatile compounds from space mixed with gases sublimating from the surface ice. It wouldn't be breathable air, we're talking about a toxic mixture of methane, ammonia, and exotic hydrocarbons, but it would be an atmosphere nonetheless. And here's where things get really fascinating from a planetary evolution standpoint. The gravitational interactions with passing star systems wouldn't just bring new matter to Earth, they'd also start affecting our orbit in unpredictable ways. Our dead planet could be nudged closer to the Sun, or pushed farther out into the cold depths of space. It might even be captured by a passing brown dwarf star, beginning an entirely new chapter as a moon in an alien solar system. But let's focus on the scenario where Earth gets nudged inward, closer to our aging Sun. The increased solar radiation would begin the slow process of warming the frozen surface. This wouldn't be a return to the lush living world we once knew, that Earth is gone forever. Instead, we'd be looking at the birth of something entirely new, a planet with no evolutionary history, no complex ecosystems, just the raw potential for life to begin again from scratch. The thick ice covering the oceans would start to melt from below as geothermal energy from radioactive decay in the planet's interior finally builds up enough heat to matter again. Without the molten core to drive plate tectonics, this process would be incredibly slow and uneven. Some regions might develop liquid water while others remained frozen solid for millions of years longer. In these scattered pockets of liquid water, protected by miles of ice above and warmed by the planet's faint internal heat, something extraordinary could happen. Those extremophile organisms that had been waiting dormant in the rock for eons would finally encounter conditions suitable for active life again. But they wouldn't be returning to a world they recognized. The chemistry of this new Earth would be completely alien. The atmosphere would be composed of gases that had never existed in significant quantities during the planet's living phase. The water would be saturated with minerals leached from rock over millions of years of freezing and thawing. The radiation environment would be completely different due to the lack of a magnetic field and the changed atmospheric composition. These awakening organisms would face evolutionary pressures unlike anything in Earth's history. They'd need to adapt to chemical environments that had never existed before, to energy sources that were entirely novel, to a planet that bore no resemblance to the world their ancestors had known. Some would die out immediately, unable to cope with the changed conditions, but others, the most adaptable, the most resilient, would begin to evolve in directions that would make them utterly alien to any life form that had ever existed on Earth. Picture bacteria that feed on the exotic atmospheric chemistry, organisms that use the planet's weak radioactivity as an energy source, microbes that can survive in the mixed ice-water environments that would dominate this new world. They wouldn't be restoring Earth's old ecosystem, they'd be creating something that had never existed before in the universe. But even this resurrection wouldn't last forever, because our sun itself is aging and evolving. As it burns through its nuclear fuel, it's gradually getting brighter and hotter. In about 1 billion years, it will enter the red giant phase, expanding to potentially engulf the inner planets entirely. Our resurrected Earth, with its strange new life forms and alien chemistry, would face its final destruction in the nuclear fires of our dying star. Unless, of course, something even more extraordinary happened first. You see, there's a possibility we haven't considered yet, and it's one that would completely change the trajectory of this story. What if, in the billions of years between Earth's death and the Sun's expansion, the planet encountered something truly unexpected? What if our frozen dead world crossed paths with another planet, maybe a rogue world ejected from a distant star system, or a massive asteroid rich in radioactive materials? A collision with another planetary body wouldn't just be destruction. It could be resurrection on a scale we can barely imagine. The impact would release enormous amounts of energy, potentially enough to remelt the entire planet and start the geological processes all over again. We'd be looking at a complete planetary reformation, a chance for Earth to be born again with an entirely new internal structure. The debris from such a collision could even form a new moon, re-establishing the tidal forces that help stabilize planetary rotation and climate. If the impacting body brought with it a significant amount of radioactive material, it could provide the internal heat source needed to restart plate tectonics and create a new molten core. This reborn Earth would be something unprecedented in the solar system, a planet with 2 distinct evolutionary histories separated by billions of years of death. The rock layers would tell an incredible story. First the remains of our original biosphere, then the long frozen period, then the explosion of new geological activity that marked the planet's second birth. But here's what makes this scenario truly mind-bending. If life did emerge again on this twice-born Earth, it would be starting from a completely different chemical and physical foundation than the first time. The basic building blocks would be different, The available energy sources would be different. Even the fundamental physics of how the planet operates would be different. We might see the evolution of life forms based on entirely different chemistry. Maybe silicon-based instead of carbon-based. Maybe organisms that use exotic isotopes created in the collision as their primary energy source. These wouldn't be aliens visiting Earth. They'd be genuinely terrestrial life forms that would be completely alien to anything that had ever lived here before. And here's the strangest part of this entire thought experiment. If you could somehow travel to this far future twice-born Earth and examine its geology, you might find fossils and chemical signatures from our current biosphere preserved in the deepest rock layers. To these future organisms, if they ever evolved intelligence, we would be the mysterious ancient civilization that they could barely comprehend. They might find traces of our cities compressed into strange mineral formations. They might discover the chemical signatures of our industrial civilization in thin layers of sediment. They might even find evidence of nuclear technology in the form of unusual isotope ratios. And they'd have no idea what to make of it, because the physics and chemistry of their world would be so different from ours that our technology would seem impossible. In a very real sense, by cooling Earth's core instantly, we wouldn't just be ending one story. We'd be setting the stage for an entirely new chapter in planetary evolution, one that could potentially dwarf our own civilization's impact on the world. The cooling of the core wouldn't be the end of Earth's story. It would be the end of the first volume in a cosmic epic that could span tens of billions of years. But let's bring this back to a more human scale, because there's one more aspect of this scenario that we need to consider, and it's perhaps the most profound of all. What would it mean for us as a species to know that our planet is capable of such complete transformation? Right now, we live with the illusion that Earth is permanent, that the ground beneath our feet is solid and reliable, that the systems that keep us alive will continue functioning indefinitely. But the reality is that our planet is an incredibly complex, delicately balanced machine, and like any machine, it can break down. The Earth's core cooling instantly is an extreme scenario, but it highlights just how dependent we are on systems that we can't control, can't repair, and barely understand. Our entire civilization exists at the mercy of a molten metal dynamo spinning in the center of the Earth, and most people never even think about it. This thought experiment forces us to confront some uncomfortable truths about our place in the universe. We're not the masters of our world. We're temporary passengers on a planet that has its own agenda, its own timeline, its own ultimate fate that may have nothing to do with our hopes and dreams. But there's something oddly comforting about this perspective too. It reminds us that we're part of something much larger than ourselves, participants in a cosmic story that stretches across billions of years and encompasses forces and phenomena that dwarf our everyday concerns. Our individual lives, our civilizations, even our entire species are just brief chapters in a story that's still being written. The cooling of Earth's core would end our chapter, but it wouldn't end the book. The planet would continue, the solar system would continue, the universe would continue its long, slow dance of creation and destruction, death and rebirth, entropy and emergence. And somewhere in that cosmic story, the brief flicker of human consciousness that witnessed and understood these processes would become part of the eternal record, embedded in the deep structure of space and time itself. So when you're lying in bed tonight, listening to the quiet sounds of the world around you, remember that beneath your feet is a furnace that's been burning for 4 billion years, keeping our entire world alive with its heat and motion. Feel grateful for every stable day, every predictable sunrise, every ordinary moment when the ground stays solid beneath your feet. Because in the vast theatre of cosmic possibilities, the fact that you exist at all, on a planet with liquid water and breathable air and a magnetic field to protect you from radiation, during the brief window when complex life is possible, is more miraculous than any science fiction story ever conceived. The Earth's core is still spinning, still churning, still generating the invisible forces that make life possible. But it won't do so forever, and neither will we. The question isn't whether our story will end. It's what we'll do with the time we have while the furnace beneath our feet continues to burn. And that brings us to perhaps the most unsettling realization of all. We've been living our entire existence on borrowed time, completely unaware that we're dancing on the edge of an abyss that could open at any moment. Think about this for a second. Right now, as you're watching this video, there are early warning systems monitoring earthquake activity, volcanic eruptions, solar flares, all the surface-level threats we can see coming. But there's no early warning system for core cooling. No satellite can peer through thousands of kilometers of solid rock to check if our planet's heart is still beating. No seismograph can detect the moment when that 4 billion-year-old engine decides to quit. We'd only know it was happening when the effects started cascading through every system on Earth, and by then, it would already be far too late to do anything except watch our world transform into something unrecognizable. But here's where this gets really mind-bending, and this is something that keeps me up at night thinking about the sheer scale of what we're dealing with. The energy contained in Earth's core right now, we're talking about more power than humanity has used in our entire existence, concentrated in a space smaller than the moon, spinning and churning just beneath our feet. When I say the core is hot, I'm talking about temperatures that would vaporize any material you can think of instantly. Steel, diamond, tungsten, they'd all turn to gas before they even got close to core temperatures. And this isn't some distant furnace we're talking about. If you could somehow drill straight down from where you're sitting right now, you'd reach this inferno in less time than it takes to drive across a large city. The fact that we're not only surviving, but thriving on top of this cosmic blast furnace is like building a house on top of an active nuclear reactor and somehow managing to live there comfortably for millions of generations. It's so improbable that if you described it to an alien civilization, they'd probably assume you were talking about science fiction. Now let's talk about something that'll really mess with your head. The scenario we've been exploring, instant core cooling, is actually not even close to the worst thing that could happen to our planet. There are cosmic events, stellar phenomena, and quantum mechanical possibilities that could make everything we've discussed look like a minor inconvenience. But what makes core cooling uniquely terrifying is that it would come from within. Every other planetary disaster we can imagine, asteroid impacts, gamma-ray bursts, solar flares, these are external threats that we could potentially see coming or defend against with sufficient technology. Core cooling would be our own planet betraying us, the very foundation of our existence deciding to stop functioning with no warning whatsoever. It's like discovering that your own heart could just decide to stop beating at any moment, for no reason, with no symptoms, and there's absolutely nothing you could do to prevent it or fix it once it happened. And here's something that'll make you look at your daily routine completely differently. Every mundane thing you do, brushing your teeth, checking your phone, driving to work, you're doing it while balanced on a knife's edge of cosmic probability. The only reason any of these ordinary activities are possible is because of an incredibly complex chain of physical processes that have to work perfectly, simultaneously, every second of every day. Your morning coffee exists because plate tectonics created mountains where coffee plants could grow. Your smartphone works because the magnetic field protects the satellites that carry your data. Your car runs on fuel that formed because geological processes buried organic matter under just the right conditions of heat and pressure. Every single aspect of modern life depends on the Earth being exactly the kind of planet it is right now, with exactly the internal structure it currently has. Remove any one element of that system, and the whole house of cards comes tumbling down. But here's where this story takes a turn that might actually give you some hope. Because while we've been focused on the catastrophic aspects of core cooling, there's another side to this that reveals something profound about the nature of existence itself. See, the fact that we're here at all, having this conversation, thinking these thoughts, means that we're living during what might be the most improbable period in the entire history of the universe. We exist during the brief, cosmic moment when stars are stable, when rocky planets can maintain liquid water, when the conditions for complex chemistry and eventually consciousness are possible. Before this epoch, the universe was too young and chaotic for life. After this epoch, it'll be too old and cold. We're living in what cosmologists call the Goldilocks period of cosmic history. Not too early, not too late, but just right for beings like us to emerge and contemplate our own existence. From this perspective, the fact that Earth's core could cool and end our story isn't a cosmic injustice. It's just part of the natural ebb and flow of a universe that's constantly creating and destroying, building up complexity and then tearing it down again. We're not victims of cosmic cruelty. We're participants in the most extraordinary phenomenon the universe has ever produced, the emergence of matter that can think about itself. And that realization leads to something even more profound. If consciousness could emerge once in this universe, under the specific conditions that exist on Earth, during this particular cosmic era, then it could potentially emerge again, somewhere else, under different conditions we can't even imagine. The extremophile organisms we talked about earlier, those alien bacteria living in conditions that would instantly kill us, they represent just the tiniest glimpse of how creative the universe can be when it comes to generating life. If single-celled organisms can thrive in boiling acid or freezing ammonia, what other forms might consciousness take on worlds we haven't discovered yet? Maybe there are civilizations right now living in the atmospheres of gas giants, beings made of plasma swimming through the coronas of stars, or digital consciousnesses encoded in the quantum fluctuations of empty space itself. The cooling of Earth's core might end our particular story, but it wouldn't end the universe's capacity to create new stories we can't even conceive of yet. And here's the really wild part. Those future forms of consciousness might look back at us the same way we look at those deep Earth bacteria. They might find evidence of our civilization preserved in some form and think, how quaint that there was once a form of consciousness that needed liquid water and a specific atmospheric composition and a narrow temperature range to survive. How limited they must have been, trapped on the surface of a single planet, dependent on such fragile conditions. But they'd be missing something crucial, something that makes our particular form of consciousness special in ways they might never understand. We exist during the one cosmic era when it's possible to see the entire history of the universe laid out in the light from distant stars. We can look up at the night sky and literally see the past, observe galaxies as they existed billions of years ago, trace the evolution of the cosmos from its earliest moments to the present. Future forms of consciousness might be more resilient, more adaptable, more capable of surviving cosmic catastrophes, but they'll never again have the opportunity to witness the universe's youth the way we can. By the time they emerge, all the most distant galaxies will have receded beyond the cosmic horizon, their light red shifted into invisibility. The cosmic microwave background radiation that tells us about the Big Bang will have cooled to the point where it's undetectable. We are the universe's memory keepers, the only form of consciousness that emerged at just the right time to observe and record the full story of how everything came to be. In a very real sense, we are the universe becoming aware of itself at the one moment in cosmic history when it's possible to understand its own origins. So when Earth's core eventually cools, whether instantly in our thought experiment or gradually over the billions of years that scientists predict, we won't just be losing a planet. We'll be losing the universe's best chance to understand itself, to preserve the memory of its own creation, to bear witness to the extraordinary chain of events that led from the Big Bang to the emergence of consciousness. That's a responsibility that goes far beyond just trying to survive as a species. It's about recognizing that we are the universe's way of experiencing wonder, of asking questions, of seeking meaning in the vast cosmic story we're all part of. And maybe that's the real lesson of our core cooling thought experiment. Not that we're helpless in the face of cosmic forces beyond our control, but that we're precious beyond measure precisely because we exist at all. We're not just random collections of atoms that happen to organize themselves into thinking beings. We're the universe's greatest achievement, its most improbable creation, its only known method of contemplating its own existence. Every sunset you watch, every conversation you have, every moment of love or wonder or curiosity you experience, these aren't just personal experiences. They're cosmic events, instances of the universe becoming conscious of its own beauty and mystery through your awareness. The furnace beneath your feet will keep burning for now, maintaining the delicate conditions that make your existence possible. But even when it eventually cools, even when our particular chapter in the cosmic story comes to an end, the fact that we existed at all will remain part of the eternal structure of reality. We are the universe's way of knowing itself, and that knowledge, once gained, can never be lost. It becomes part of the fundamental fabric of existence, encoded in the quantum fields that underlie all reality, preserved in ways that transcend the mere survival of planets or species or even stars. So the next time you feel small or insignificant in the face of the vast cosmos, remember this. You're not separate from the universe observing it from the outside. You're the universe itself, experiencing its own grandeur through your consciousness, asking its own questions through your curiosity, expressing its own creativity through your imagination. The Earth's core spinning beneath your feet isn't just keeping you alive, it's enabling the universe to be alive to itself through you, and that might just be the most extraordinary thing that's ever happened in the entire 14 billion year history of everything that exists. The spinning, molten core beneath our feet isn't just maintaining our planet's magnetic field and keeping continents stable, it's also doing something that most people never realize. It's acting as a massive time machine, preserving a record of Earth's entire history in ways that would make the most advanced computer storage system look primitive. You see, as that liquid iron churns and flows, it's constantly recording magnetic signatures from every major event in Earth's past. Asteroid impacts, volcanic eruptions, even the rise and fall of entire species. All of it gets encoded in the magnetic patterns frozen into cooling lava flows and sedimentary layers. Scientists call this paleomagnetism, and it's like having a 4-billion-year-old hard drive spinning at the center of our planet. When the core suddenly freezes solid, we wouldn't just be losing our magnetic field and geological stability, we'd be losing the universe's most complete record of planetary evolution. Every magnetic reversal, every impact event, every climate shift that's ever occurred on Earth, all of that information would be locked forever in a solid chunk of metal that we could never access again. Think about what that means from a cosmic perspective. Earth isn't just our home, it's potentially the only planet in the observable universe where complex life evolved to the point of developing technology and consciousness. And locked in our planet's magnetic memory banks is the complete story of how that happened. Every evolutionary leap, every mass extinction, every environmental change that led to the emergence of intelligence. It's all there, recorded in magnetic patterns that span geological epochs. But here's where this gets really profound, and it's something that would haunt any survivors of the core cooling event. They'd realize they were witnessing the death of not just their civilization, but of the universe's memory itself. All the information about how life can emerge from non-living matter, how consciousness can arise from simple chemistry, how intelligence can develop the capacity to understand its own origins, all of that would be lost forever. The frozen core wouldn't just be a dead chunk of metal. It would be a sealed tomb containing the most valuable information in the known universe, and there would be absolutely no way to retrieve it. Future civilizations, if any ever emerged, would be starting from scratch with no record of the billions of years of trial and error that led to successful complexity. But let's dig deeper into what happens during those first critical hours after the cooling event, because there's something even more terrifying that we haven't discussed yet. The electromagnetic pulse. When Earth's magnetic field collapses, it doesn't just fade away gradually like a dying light bulb, it collapses catastrophically, creating a planetary-scale electromagnetic pulse that would make the most powerful nuclear EMP look like a camera flash. Every electronic device on Earth would be fried simultaneously, not damaged, not disrupted, completely destroyed at the circuit level. Picture this. You're watching this video on your phone when suddenly the screen goes black. Not just your phone, every computer, every satellite, every piece of electronic equipment on the planet dies at exactly the same moment. The silence would be deafening. No radio signals, no internet, no GPS, no electronic communication of any kind. Humanity would be instantly thrown back to a pre-electronic age, but without any of the infrastructure or knowledge needed to survive in that kind of world. Modern cities would become death traps within hours. Elevators would stop between floors. Electronic door locks would fail, trapping people in buildings or keeping them out of essential facilities. Water treatment plants would shut down. Power grids would collapse. Emergency services would be completely paralyzed because all their communication equipment would be dead. But here's what makes this even more catastrophic than any other EMP scenario ever imagined. This wouldn't be a temporary disruption that engineers could eventually repair. The collapse of the magnetic field would create ongoing electromagnetic chaos that would prevent any electronic device from functioning properly even if it could somehow be rebuilt. The solar wind and cosmic radiation, no longer deflected by our magnetic shield, would create constant electromagnetic interference. Any attempt to restart electronic systems would fail as soon as the circuits were exposed to the new radiation environment. Humanity would be permanently locked out of the digital age, forced to rebuild civilization using only mechanical and chemical technologies. Now imagine being one of the few people who understood what was happening. Maybe you're a physicist or an electrical engineer, and you realize that the simultaneous failure of all electronic systems means something catastrophic has happened to Earth's magnetic field. You'd know with absolute certainty that this isn't a temporary crisis that society will recover from. This is the beginning of the end of technological civilization. You'd probably try to warn people, to explain what was happening, but how do you communicate that message when all communication systems are dead? You'd be limited to word of mouth, to physically traveling from place to place. trying to convince people that they need to prepare for geological catastrophes that are still hours or days away. Most people wouldn't believe you. They'd be focused on the immediate crisis, the blackouts, the communication failures, the transportation breakdowns. They'd assume it was some kind of cyber attack or solar flare, something that engineers would fix within days or weeks. The idea that their planet's core had stopped working would sound like science fiction. And even if you could convince people, what would you tell them to do? There's no preparing for magnitude 12 earthquakes or worldwide volcanic eruptions. There's no safe place to go when the entire planetary crust becomes unstable. The best you could do would be to gather supplies and head for the most geologically stable areas you could think of, knowing that even those wouldn't remain stable for long. But here's where human psychology becomes both our greatest weakness and our strangest strength. Faced with absolute catastrophe, some people would completely shut down, unable to process the magnitude of what was happening. Others would go into denial, convincing themselves that everything would somehow return to normal. But a few, a precious few, would experience something that psychologists call disaster transcendence. These individuals would suddenly develop capabilities they never knew they had. Ordinary people would become natural leaders, organizing survival efforts with calm efficiency. Introverts would find themselves capable of inspiring and coordinating large groups. People who had never shown particular courage would risk their lives repeatedly to save others. It's as if the human spirit, when faced with absolute extinction, unlocks hidden potentials that remain dormant during normal times. These transcendent individuals would become the backbone of any survival communities that managed to form in the chaos following the electromagnetic collapse. They'd be the ones who remembered that humans lived for thousands of years without electronics, who could organize people to dig wells by hand, who could figure out how to preserve food without refrigeration, who could treat injuries without modern medical equipment. They'd become living bridges between the technological world that had just died and the primitive world that survivors would need to create. But even these remarkable individuals would face challenges that no human society had ever encountered. Because while they're trying to organize basic survival in a world without electronics, the geological disasters would be building toward a crescendo that would make their efforts seem almost tragically futile. The earthquakes that begin in the first few hours would follow a pattern that geologists call cascade amplification. Each major quake would trigger dozens of smaller ones, but those smaller quakes would destabilize fault lines that had been stable for thousands of years. Within days, you'd have earthquake swarms affecting regions that had never experienced significant seismic activity. Picture Manhattan, built on some of the most geologically stable bedrock on the continent, suddenly experiencing magnitude 8 earthquakes every few hours. The skyscrapers, designed to sway slightly in the wind but never engineered for serious seismic activity, would start collapsing like dominoes. But it wouldn't just be the tall buildings. The entire subway system would collapse as the bedrock shifted, creating underground caverns that would swallow city blocks. London, Paris, Berlin, cities built over centuries with no consideration for earthquake resistance, would be reduced to rubble within the first week. But the real horror would be in places like Tokyo and San Francisco, cities that had spent billions of dollars earthquake-proofing their infrastructure based on the assumption that they knew what the worst-case scenario looked like. Their earthquake-resistant buildings would hold up initially, giving residents false hope that their preparations had worked. But then the magnitude 11 and 12 quakes would hit, seismic events so far beyond anything in recorded history that no human engineering could withstand them. Watching those supposedly indestructible structures collapse would break the spirit of survivors in ways that might never heal. So the next time you feel the solid ground beneath your feet, remember that you're standing on the thinnest possible shell above a churning inferno that's been burning since before life itself existed. That molten metal dynamo spinning in the darkness below isn't just keeping you alive, it's preserving the universe's memory, maintaining the only known record of how consciousness can emerge from cosmic chaos. We exist in the most improbable moment in all of history, witnesses to our own origins, keepers of knowledge that will outlast stars themselves.